In this video, we're going to talk about how to determine whether a value c is a 0 of a certain f of x polynomial, and then also how to determine whether x minus c is a factor of that same polynomial function. So before we get to how we're going to do that, I want to make sure we understand what a 0 is and what a factor is. So let's start with something we should be pretty familiar with, which is a quadratic function. We learned lots of ways to solve quadratic functions, factoring being one of the ones we did most often. And when we have a polynomial like this, we know that we can factor it. We're looking for numbers that multiply to get negative 21 and add to get negative 4. And those would be negative 7 and positive 3. So this is the factored form of the polynomial. So we call x minus 7 and x plus 3 factors of this polynomial. All right? And if these are factors, then values that make either of these factors equal 0 are what we call zeros of the polynomial. So if we set that equal to 0, we get 7. If we set this factor equal to 0, we get negative 3. So 7 and negative 3 are what we call zeros of the polynomial. Okay. Also, if we were to plug these back in, up here, they would give us a f of x value of 0. Okay, so any zeros, when you plug them in, will give you 0, just like here. If I plug it in here, it gives me 0. If I plugged it in up here for x, it would give me 0. These are called the factors. These are called the zeros. Now, we might also have a cubic function that would factor as well. So we could find the zeros and the factors for this function. You see here we've got 4 terms, and when we learned our factoring methods, we learned that when we have 4 terms, we can try factoring by grouping. So I'm going to try that here, and I see that in my first group I can factor out an x squared, which is going to leave me with 2x minus 1. In my second group, I can factor out a negative 4, which leaves me with 2x minus 1. And then I end up with x squared minus 4 and 2x minus 1. And hopefully we see that this factor can break down even further as the difference of squares. So that breaks down to x plus 2 and x minus 2. And then we have 2x minus 1. So this is the factored form of that polynomial. So these are called the factors. X plus 2 is a factor, x minus 2 is a factor, 2x minus 1 is a factor. And if those are factors, then my zeros will be the values that make each of those equal 0. So my 0 here will be negative 2. Here will be positive 2, and here my 0 will be 1/2. So these are called the zeros. Now we also will call those, you'll hear them called solutions. You'll hear them called, they also correspond to the x-intercepts if we were graphing the function. But right now we're going to be calling them zeros. Okay, now that's good and fine as long as this polynomial will factor. But what are we going to do when I have a polynomial where we have not learned a way to factor it? Let's look at this one. Okay, so this is quite a polynomial here. We don't know a way to factor this, but we are going to learn today how to tell whether a value is a 0 of this, and also whether a factor is a factor of this using synthetic division. So we're going to start with the question, is x plus 5 a factor of this polynomial f of x? Well, if we were able to factor it and break it down and get it into factored form, we could just examine the factors and see if x plus 5 is one of them. But since we don't know how to factor this, we're going to have to go a different route. So, another thing we can use is the definition of a factor. If something is a factor of something else, it means it divides into that thing evenly. Like if I ask you, is 3 a factor of 12? Well, the answer to that is yes, and we know that because 3 divides evenly into 12 with no remainder. So 12 divided by 3 comes out to be a nice 4, no remainder. So yes, 3 is a factor of 12. So if I want to know if x plus 5 is a factor of this, I can divide this polynomial by x plus 5 and see if I get a remainder. If I don't get a remainder, then the answer is yes, this is a factor. So this is where synthetic division comes in. We're going to divide this polynomial by x plus 5 using synthetic division and see if we have a remainder or not. So remember, in synthetic division, if you're trying to divide by x plus 5, you're going to put negative 5 here in the box. We're going to bring the coefficients down from the polynomial. That's going to be a 1, an 11, a 41, a 61, and a 30. I'm going to do synthetic division. I'm going to bring the 1 down, loop around and multiply. Combine these, multiply. Combine these and multiply. Combine these and multiply one last time. And you see that my last number here is a 0. This last number is always your remainder. Since we have a remainder of 0, that tells us that yes, x plus 5 is in fact a factor of this polynomial. And if x plus 5 is a factor, we also know, let's write this down, if x plus 5 is a factor, one other thing we know is that negative 5 is a 0. So let's just keep that in mind. Just like up here, if x minus 7 is a factor, then 7 is a 0. If x plus 3 is a factor, then negative 3 is a 0. So when I did this division and I found out that x plus 5 is a factor, then that tells me also that negative 5 is a 0. Okay? We're going to take that same polynomial. I'll do it up here so I don't have to look back at this page. I'm going to take the same polynomial and I'm going to ask the question, is x minus 2 a factor of that polynomial, f of x? Alright, so we're going to do the same thing to check to see if x minus 2 is a factor. We're going to divide this polynomial by x minus 2 using synthetic division. So to do that, I'm going to put positive 2 in the box. I'm going to bring these same coefficients of the polynomial up here so I can do synthetic division. Bring the 1 straight down, loop around and multiply, combine those, loop around and multiply. 67, woo, 67 times 2 is 134. We add that, we get 195. I can go ahead and tell you I don't even need to finish this out, because if I do 195 times 2, it's going to give me some number that's almost 400. This is not going to give me 0 right here. So I can go ahead and say no, that is not a factor, because I know I'm going to have a remainder here. And if x minus 2 is not a factor, then I know that positive 2 is not a 0. Okay, so x minus 2 is not a factor. Let's do one more for this particular polynomial. Is x plus 2 a factor of the polynomial? All right, let's check and see using synthetic division. So if we're going to divide this polynomial by x plus 2, then I'm going to put negative 2 in the box. I'm going to bring my coefficients over here and start synthetic division again. Bring the 1 straight down, loop around and multiply, combine those, and multiply. What is that? Let's see, 23, I think. 23 times negative 2 is negative 46. I believe that's 15. 15 times negative 2 is negative 30. Again, here we get a remainder of 0. That tells us that x plus 2 is a factor of this polynomial. So in other words, if we broke this down, if we were able to, we now know that x plus 5 is a factor and x plus 2 is a factor. Those would be at least two. Those would be two of the factors. We would need two more. And we're going to go on in the next section to learn different ways to find the remaining factors. But right now we're just learning to determine if one thing is a factor of the polynomial. And so yes, x plus 2 is a factor, and also yes, x plus 5 is a factor. X minus 2 is not, because we're going to get a remainder on that one. Okay, so now we need to do that same thing, but we need to review how to do that with square roots and possibly with some complex numbers. So let's try one like this. Is x minus 2 square roots of 2 a factor of the polynomial 2x cubed plus x squared minus 16x minus 8. Okay, so if we want to see if this is a factor of this, then we can use synthetic division to divide this by this. Now when we do that, we always put the opposite of this in the box. So we would put 2 square roots of 2, positive 2 square roots of 2 in the box. I'm going to bring these coefficients down. I've got a 2, a 1, a negative 16, and a negative 8. And I am going to do synthetic division here. It's not as easy as when we just had nice integer numbers, but we can still do it. We're going to bring that positive 2 straight down. We're going to multiply 2 times 2 square roots of 2, and that's 4 square roots of 2. Then we're supposed to add these. Well, you can't add something with a square root on it and something that doesn't have a square root, so that's going to give you 4 square roots of 2 plus 1. And then we're going to have to take that and multiply it by 2 square roots of 2. So I'm going to do that down here. Multiplying 2 square roots of 2 times 4 square roots of 2 plus 1. So I'll have to distribute. 2 times 4 is 8. Square root of 2 times square root of 2 is 2. And then 2 square roots of 2 times 1 is 2 square roots of 2. And that gives me 16 plus 2 square roots of 2. All right, that's going to go here. And then when I combine these, you see that my 16s are going to cancel out, a negative 16 and a positive 16. So I'm just going to end up with 2 square roots of 2. Then I have to multiply 2 square roots of 2 times 2 square roots of 2. And I multiply these numbers in front of the radicals together. And then I'll multiply the radicals together. Square root of 2 times square root of 2 is 2. So that gives me 8, which goes here. And you see that that, in fact, makes 0 as my remainder. So the answer to this question is yes. X minus 2 square roots of 2 is a factor of this polynomial. And in addition to that, if we know this is a factor, then we know that this is a 0. Okay? All right, now let's try one with a complex number or an imaginary number. Is x plus 5i a factor of the polynomial function x cubed minus 2x squared plus 25x minus 50? All right. So if we want to check to see if this is a factor, we're going to use synthetic division, and we're going to divide this polynomial by x plus 5i and see if we get a remainder. All right, so if this is x plus 5i, we're going to put negative 5i in the box. We're going to bring down our coefficients of all of these terms, 1, negative 2, 25, and negative 50. I'm going to do synthetic division. Bring down the 1. 1 times negative 5i is negative 5i. Now we can't combine these. We just have to write it negative 2 minus 5i. And then we're going to have to multiply that by negative 5i. So I'm going to do that right here. I'm going to distribute negative 5i times negative 2 is positive 10i. Negative 5i times negative 5i is positive 25i squared. Remember that I squared gives us negative 1. So 10i plus negative 25, or 10i minus 25 is what we get. All right, that's going to go here. And then we got to combine these, and we see that the 25s are going to go away, and we'll have 10i. And then we have to multiply 10i times negative 5i. 10 times negative 5 is negative 50, I squared. Well, I squared is negative 1, so this comes out positive 50. And it does give us a remainder of 0. So the answer here is also yes. X plus 5i is a factor of this function, or this polynomial function, and that also tells us that negative 5i is a 0 or a solution. Okay, so we've covered how to tell if something is a factor, all right? And really, we've covered how to tell whether something is a 0, but we'll do a few like that. Let's see here. I'm just gonna paste. All right, so let's say we have this function. And I want to know, is 4 a 0 of this function? Well, we just learned how to tell if something like x minus 4 is a factor. If you just want to tell if this value is a 0, then you will just do synthetic division, putting that number right here. So is 4 a 0? Well, we're going to divide this by x minus 4, which basically means just put a positive 4 right here, and bring your coefficients down to negative 4, negative 13, negative 9. Bring that straight down. We're going to loop around and multiply, combine, multiply, combine, multiply, and we get a remainder of 3. And since we get a remainder of 3, no, 4 is not a 0. 4 is only a 0 if we get a remainder of 0. All right, let's try another one. If we have this function, x cubed plus x squared minus 3x minus 3, and I want to know, is the square root of 3 a 0? Okay, well, I can do synthetic division with the square root of 3. Bring my coefficients down, 1, 1, negative 3, negative 3. Do synthetic division. Now it's a little bit more difficult with the radical, but we can do it. 1 times the square root of 3, square root of 3. When we combine these, we get 1 plus the square root of 3. We have to multiply that by the square root of 3, so I'm going to do it down here. Distribute. Square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3 is 3. So right here I get the square root of 3 plus 3. As you can see, my 3's will zero out and I'll have square root of 3. Square root of 3 times square root of 3 is positive 3. 0 remainder. So is the square root of 3 a 0 of this? Yes, it is. Okay. One more like this. Here's my polynomial, x cubed plus x plus 10. And I want to know, is 1 plus 2i a 0 of that polynomial function? All right, so I'm going to synthetically divide by 1 plus 2i. Now, notice in my polynomial that I skipped my x squared term, so I can't leave that out. I've got to put a 0 in for the coefficient of my x squared term. So the 1 is for the x cubed, 0 is for the missing x squared, 1 for the x, and then 10. Alright, I'm going to bring my 1 straight down. 1 times 1 plus 2i is 1 plus 2i. Add that to 0, that's just going to be 1 plus 2i. But now I've got to multiply 1 plus 2i times 1 plus 2i. I'm going to do it over here because I've got to distribute this out. 1 times 1 is 1. 1 times 2i is 2i. 2i times 1 is 2i. And 2i times 2i is 4i squared. Alright, I can combine these 2i's and 2i is 4i. 4 times I squared is negative 1, so that comes out negative 4. And then 1 minus 4 is negative 3 plus 4i. So that goes here, negative 3 plus 4i. Alright, if I add that with the 1, then I'm going to end up with negative 2 plus 4i. And I'm going to have to come over here again because I need to multiply negative 2 plus 4i and 1 plus 2i together. Alright, so I'm going to distribute again. Negative 2 times 1 is negative 2. Negative 2 times 2i is negative 4i. Positive 4i times 1 is positive 4i. 4i times 2i is 8i squared. Alright, those end up canceling out. I have negative 2 plus 8 times negative 1. So negative 2 and negative 8 gives me negative 10. That goes here, and I end up with a remainder of 0, which means that 1 plus 2i is a 0. And we've answered the question, but I want to go back and I want to remind you, if square root of 3 is a 0, then we also know that this is a factor. Okay, even though that's funny looking. If 1 plus 2i is a 0, then we also know that this is a factor. Okay, x minus this is a factor. Okay, so all of this is going to come in handy as we move into the next topics. I'm going to do one other type of problem here based on what we have talked about in this video. Alright, what if you were asked to factor this polynomial 3x cubed plus 25x squared plus 42x minus 40, given that negative 5 is a zero of this function. Okay, well, it looks like we might potentially be able to factor this. We have 4 terms and we could try factoring by grouping, but I'm going to go ahead and tell you it's not going to work. So that's why we're learning these new methods, because every polynomial will not just factor, and we're going to have to use other methods like synthetic division to get the polynomial into factored form. So we are given this information that negative 5 is in fact a zero of this polynomial. And so we know that if negative 5 is a zero, then x plus 5 is a factor. So we at least have one factor of the polynomial. So we know that it's going to break down. We're going to have an x plus 5, and then we're going to have something else. Potentially, we need 2 more factors to come up with a cubic function. So what would those other 2 factors be? Well, what we can do is we can use synthetic division to divide this polynomial by the factor that we do know, and we can see what's left. So let's do that. So if negative 5 is the zero, then we're going to put in negative 5 in the box. We're going to bring our coefficients down from the polynomial, and we're going to do synthetic division. I'm going to bring the 3 straight down. I'm going to multiply. I'm going to combine those. I'm going to multiply, combine those, multiply, and you see we get that remainder of 0, which we should get because we were told that that is a 0. Now, why did we do that if we already knew that was a 0? We did it to see what's left, okay? So when we divide a cubic function by x plus 5, remember our answer is going to be 1 degree less than this. These are the coefficients of what's left. So what we have now is we have x plus 5 times 3x squared plus 10x minus 8. Okay, these two would multiply together to give us the original function that we started with. Okay, it's just like saying if I divide 15 divided by 3 and I get 5, then 3 times 5 gives me 15. Okay, the thing you divided by, the divisor, and the quotient multiplied together will give you the dividend. All right, this is the dividend. If we divided by this and got this, then we can multiply these together to get this. So this is what this polynomial looks like as we've started to break it down, given the factor that we were given, and now what's left when we divide by that. Now this is a trinomial, quadratic trinomial, that can be factored, and so we can use the AC method to factor this polynomial. 3 times negative 8 is negative 24. Factors of negative 24 that give us 10 are positive 12 and negative 2. And we can group. And we end up with 3x minus 2 and x plus 4. So what we now have is we have x plus 5, and then we factored this to 3x minus 2 and x plus 4. And we have our original function completely factored. So these are the factors. Now if we wanted to find the zeros, we could easily now find the zeros. The zeros would be values that make these zeros. So -5, 2/3, and -4. These are my zeros. Okay, so now you've learned that we can take a given factor or a given zero and we can use synthetic division, divide, see what we have left, and if it's quadratic, we could potentially factor that to get this all the way in factored form. Now, as we move on to the next topics, we're going to see other methods that we can use to get it into completely factored form. But I thought I'd go ahead and introduce that one to you here.